This training is provided by SafeShield. We're a professional training provider that specializes in cybersecurity, compliance, risk management, and AI governance. Our goal is to give professionals the knowledge and skills required to advance their careers and get ahead of the competition. This free course is part of that goal. We want to make trusted, high-quality education accessible and to support the development of responsible practices in new and emerging fields such as AI governance. Artificial intelligence systems are now embedded in critical business processes, customer interactions, and decision-making activities across industries. As organizations increasingly rely on AI, expectations around governance, accountability, risk management, and regulatory compliance continue to rise. ISO 42001 was developed to address this reality by providing a structured management system standard specifically designed for artificial intelligence. This course introduces ISO 42001 and explains how an artificial intelligence management system, or AIMS, can be implemented and audited in a systematic, auditable, and business-aligned manner. The focus of this course is practical application. Attention is placed on how organizations design, implement, operate, monitor, and continually improve an AIMS across the full AI lifecycle. Equal emphasis is given to auditing considerations, including audit scope definition, evidence collection, risk-based audit planning, and conformity assessment against ISO 42001 requirements. The course is designed to support professionals who participate in AIMS implementation projects, internal audits, supplier assessments, and certification readiness activities. By the end of this course, participants will understand the structure and intent of ISO 42001, the key components of an AIMS, and the roles and responsibilities involved in effective AI governance. Participants will also be able to distinguish between implementation activities and audit activities, understand how controls are selected and evaluated, and recognize how ISO 42001 aligns with other frameworks, such as the NIST AI Risk Management Framework and emerging regulatory requirements, including the EU AI Act. By adopting a structured, standards-aligned approach, professionals ensure that AI systems remain reliable, explainable, and beneficial to society, reinforcing the trust that underpins sustainable AI innovation. The development of ISO 42001 reflects a significant shift in how organizations and regulators view artificial intelligence. Traditional management system standards, such as ISO 27001 or ISO 9001, address information security and quality management, but they do not fully capture the unique risks and governance challenges introduced by AI systems. These challenges include algorithmic bias, lack of transparency, model drift, unintended societal impact, and complex accountability chains across data, models, and deployment environments. Global regulatory initiatives accelerated the need for a dedicated AI management system standard. Governments and regulators recognize that AI risks cannot be addressed solely through technical controls or ethical guidelines. A structured, auditable management system is required to ensure consistency, traceability, and accountability throughout the AI lifecycle. ISO 42001 was created to provide organizations with a globally recognized framework that supports responsible AI development and use while remaining flexible, enough to accommodate different industries, use cases, and maturity levels. The standard is designed to be risk-based and context-driven. It requires organizations to understand their AI objectives, stakeholders, regulatory obligations, and risk appetite before defining controls. This approach aligns ISO 42001 with modern governance practices and enables integration with enterprise risk management and compliance programs. The standard also supports assurance activities by defining requirements that can be independently audited, enabling certification and third-party assessments. As a result, ISO 42001 serves both operational governance needs and external trust and compliance expectations. ISO 42001 is applicable to any organization that develops, deploys, operates, or uses artificial intelligence systems, regardless of size, sector, or level of technical sophistication. The standard does not assume that organizations build AI models internally. It explicitly applies to organizations that acquire AI systems from third parties, integrate AI services into business processes, or rely on externally hosted AI platforms. This broad applicability reflects modern AI supply chains, where responsibility is often shared across multiple actors. The scope of an AIMS is defined by the organization and must reflect the AI systems, processes, and activities under management. Scope definition is a foundational step because it determines which AI systems are subject to governance, risk management, and audit activities. The scope may include all AI systems used by the organization or may focus on specific business units, products, or high-risk use cases. Clear scope boundaries are essential for both implementation and auditing, as they directly affect evidence collection and conformity assessment. ISO 42001 is designed to integrate with existing management systems. Organizations with established ISO 27001, ISO 9001, or ISO 22301 systems can leverage existing governance structures, documentation practices, and audit processes. This compatibility reduces duplication and supports a unified governance approach. The standard's applicability across the AI lifecycle ensures that governance is not limited to development activities, but extends to deployment, operation, monitoring, and retirement of AI systems, supporting sustained accountability over time. ISO 42001 follows the harmonized structure used by modern ISO management system standards. This structure is based on Annex SL, which ensures consistency across standards and facilitates integration with other management systems. The standard is organized into 10 main clauses, beginning with scope, normative references, and terms and definitions, and continuing with requirements related to organizational context, leadership, planning, support, operation, performance evaluation, and improvement. Clauses 4 through 10 contain the mandatory requirements that organizations must satisfy to conform to the standard. Clause 4 focuses on understanding the organization and its context, including internal and external issues relevant to AI governance. Clause 5 addresses leadership and commitment, emphasizing accountability, policy setting, and role assignment. Clause 6 covers planning activities, including risk assessment, objectives, and treatment plans. These clauses establish the strategic foundation of the AIMS. Clauses 7 and 8 address operational enablement and execution. Clause 7 defines support requirements such as competence, awareness, communication, and documented information. Clause 8 focuses on operational planning and control across the AI lifecycle. Clause 9 addresses performance evaluation, including monitoring, measurement, internal audit, and management review. Clause 10 emphasizes continual improvement through corrective actions and system enhancement. This structured approach ensures that AI governance is systematic, auditable, and continuously improved rather than ad hoc or reactive. ISO 42001 is grounded in several core principles that shape both implementation and auditing activities. One central principle is risk-based governance. The standard requires organizations to identify, analyze, and treat AI-related risks based on potential impact, likelihood, and organizational risk tolerance. This principle ensures that governance efforts are proportionate and focused on what matters most, rather than applying uniform controls across all AI systems. Another foundational principle is lifecycle coverage. AI risks evolve over time as models are trained, deployed, retrained, and integrated into changing environments. ISO 42001 requires governance controls to be applied throughout the AI lifecycle, including design, development, deployment, operation, monitoring, and retirement. This lifecycle perspective is critical for managing issues such as model drift, data quality degradation, and changing regulatory expectations. Transparency and accountability are also central to the standard. Organizations are required to define roles, responsibilities, and decision-making authorities related to AI systems. Documentation and traceability are emphasized to support internal oversight and external audits. The standard also promotes continual improvement, requiring organizations to learn from incidents, monitoring results, and audit findings. Together, these principles establish ISO 42001 as a practical management system that supports trustworthy AI while enabling assurance, certification, and regulatory alignment. An artificial intelligence management system, or AIMS, is the structured set of policies, processes, roles, controls, and records used to govern how AI systems are designed, developed, deployed, and operated within an organization. An AIMS is not a single document or tool. It is an integrated management framework that aligns AI activities with organizational objectives, risk appetite, and compliance obligations. ISO 42001 defines the minimum requirements for establishing, implementing, maintaining, and continually improving an AIMS. The system is designed to ensure that AI risks are identified and managed in a consistent and repeatable manner. This includes technical risks, such as model robustness and security, as well as organizational and societal risks, such as fairness, explainability, and accountability. The AIMS provides a mechanism to translate high-level AI principles into operational controls and decision-making processes. From an auditing perspective, the AIMS serves as the primary object of assessment. Auditors evaluate whether the system is appropriately designed, effectively implemented, and operating as intended. Evidence is collected to demonstrate conformity with ISO 42001 requirements and the organization's own policies and objectives. A well-designed AIMS enables organizations to demonstrate due diligence, support regulatory compliance, and build trust with stakeholders while maintaining flexibility to innovate and scale AI capabilities responsibly. Understanding organizational context is a foundational requirement of ISO 42001. Organizations must identify internal and external issues that affect their ability to achieve intended AIMS outcomes. Internal issues may include governance maturity, technical capabilities, organizational culture, and existing management systems. External issues may include regulatory requirements, market expectations, contractual obligations, and societal concerns related to AI use. Stakeholder identification and analysis are closely linked to context assessment. Relevant interested parties may include customers, regulators, employees, business partners, suppliers, and affected individuals or communities. Each stakeholder group may have different expectations related to transparency, fairness, safety, and accountability. ISO 42001 requires organizations to understand these expectations and determine which are applicable as compliance obligations or governance commitments. This contextual understanding informs scope definition, risk assessment, and control selection. For auditors, context and stakeholder analysis provide essential background for evaluating whether the AIMS is appropriate and proportionate. Evidence may include documented context analyses, stakeholder registers, regulatory mappings, and records of stakeholder communication. Weaknesses at this stage often lead to misaligned controls or incomplete risk coverage. A robust context assessment ensures that the AIMS reflects real organizational and societal needs rather than theoretical or generic assumptions. Leadership is the factor that determines whether an AIMS becomes a living management system or a set of disconnected documents. ISO 42001 requires top management to demonstrate commitment, set direction, and ensure that AI governance is integrated into normal business governance. The standard expects accountability to be explicit. Accountability includes approving the AI policy, ensuring objectives are defined, and making sure responsibilities are assigned with enough authority to be effective. In practice, governance roles must cover the full lifecycle. Ownership for an AI system should be clearly assigned, including accountability for intended purpose, performance expectations, and risk treatment decisions. Risk management responsibilities must include identification, assessment, treatment planning, and review triggers when systems change. Data governance responsibilities must address provenance, quality, access controls, retention, and compliance requirements. Operational responsibilities must include deployment approvals, monitoring, incident response, and retirement decisions. Evidence of leadership commitment should be visible. Management participation should appear in governance committee minutes, resourcing decisions, and formal management review outputs. Escalation paths and decision rights must be documented and understood across teams. Role clarity reduces gaps that often emerge in multi-vendor AI supply chains, where responsibility is distributed across developers, integrators, and operators. During audits, leadership commitment is assessed through both documentation and behavior. Auditors will look for consistent governance practices, timely decisions on risks and incidents, and clear alignment between strategic objectives and operational controls. An AI policy is the organization's public statement of intent and internal reference point for decisions about AI development and use. ISO 42001 expects this policy to reflect the organization's context, stakeholders, and risk appetite. The policy should be written so that it drives operational behavior. It should define governance principles relevant to the organization's AI systems, such as accountability expectations, risk-based decision-making, transparency commitments, and requirements for lifecycle oversight. A policy becomes actionable through objectives. Governance objectives translate intent into measurable targets that can be monitored and reviewed. Examples include objectives for improving risk assessment coverage, strengthening monitoring of model drift, reducing unresolved AI incidents, increasing completion rates for AI governance training, or improving documentation completeness for high-impact systems. Objectives should include metrics, targets, owners, and timeframes. This structure supports clear accountability and enables management review to evaluate progress based on evidence rather than general impressions. Alignment is critical. Objectives should connect to business outcomes and compliance obligations. If the organization operates in regulated environments, objectives may reflect external requirements, such as record retention expectations, impact assessment practices, or post-deployment monitoring commitments. If the organization relies on third-party AI services, objectives should address supplier governance and assurance activities. Auditors use the AI policy and objectives as key audit criteria. They will assess whether the policy is communicated, whether objectives are monitored, and whether decisions and controls reflect the policy's intent. Misalignment between policy statements and operational reality is a common audit finding. Risk-based planning is the core mechanism that turns ISO 42001 into a practical management system. The standard requires the organization to identify risks and opportunities that could affect intended AIMS outcomes. This work begins with context and stakeholder expectations, then translates those inputs into AI-specific risks tied to real systems, real data flows, and real operational conditions. A credible risk assessment method should be defined and documented. Risk criteria must be established, including how likelihood and impact are evaluated, how uncertainty is handled, and how risk acceptance is determined. For AI systems, impact often includes safety impacts, legal and compliance impacts, financial impacts, and impacts on individuals or groups affected by decisions. Risks frequently include bias and discrimination, insufficient transparency or explainability, model drift, data quality failures, security vulnerabilities, misuse, and failures of human oversight. Risk treatment planning defines what the organization will do about prioritized risks. Treatment options include implementing controls, changing the system design, limiting use cases, strengthening monitoring, improving training and competence, or transferring risk through contracts and supplier requirements. Treatment plans should define owners, timelines, resources, and verification methods. Auditors will examine whether the risk register reflects the actual AI inventory and whether the assessment approach is consistently applied. They will also test whether treatment actions were implemented and whether effectiveness is evaluated. Stagnant risk registers, missing reassessment triggers, and undocumented acceptance decisions are frequent weaknesses. AIMS planning must remain dynamic as systems change, data changes, and regulatory expectations evolve. Competence and awareness determine whether AIMS controls work as designed. ISO 42001 requires the organization to define the competencies needed for roles that affect AI governance outcomes and to ensure those competencies are achieved and maintained. This requirement applies to more than technical teams. It includes product owners, risk and compliance personnel, procurement teams, data stewards, operations teams, and internal auditors. Competence should be role-based. A data steward needs competence in data provenance, quality controls, access management, retention, and privacy constraints. A model owner needs competence in performance expectations, validation logic, monitoring metrics, and escalation triggers. A risk manager needs competence in AI risk taxonomy, assessment methods, and treatment planning. An auditor needs competence in management system auditing, evidence evaluation, and AI governance concepts, including lifecycle risks and control intent. Awareness is broader than competence. Awareness means people understand the AI policy, their responsibilities, the consequences of nonconformity, and how to raise concerns. Awareness also means staff can recognize when an AI system change requires reassessment, such as a new training dataset, a change decision threshold, or a new deployment environment. Auditors look for practical evidence. Training plans, completion records, competence matrices, job descriptions, and interview responses are typical evidence sources. Weaknesses often appear when training is generic, when roles are unclear, or when contractors and suppliers are excluded. AIMS effectiveness depends on consistent competence across the internal organization and across relevant external parties. Documented information is the backbone of auditability in ISO 42001. The standard requires the organization to maintain documentation necessary for the effectiveness of the AIMS and to retain records as evidence that processes are performed as planned. Documentation enables traceability, accountability, and repeatability. Records demonstrate that controls exist in practice, not only on paper. A practical AIMS documentation set usually includes the AI policy, scope statement, role assignments, risk assessment method, risk register, risk treatment plans, lifecycle procedures, and monitoring requirements. Operational documentation often includes AI system inventories, model documentation, data provenance records, validation reports, deployment approvals, monitoring dashboards or reports, incident records, change logs, and retirement decisions. Supplier documentation may include assurance reports, contractual obligations, and evidence of third-party control evaluations. Records management must address integrity, confidentiality, and accessibility. Controls should ensure that records cannot be altered without traceability, that access is limited to authorized roles, and that retention aligns with compliance needs. Version control is essential, especially when models and datasets change. Clear naming conventions and evidence linking reduce audit friction and reduce the risk of missing evidence during certification or regulatory inquiries. Auditors assess whether documentation aligns with actual practice. They will test traceability, such as linking a risk to a control, linking a control to monitoring evidence, and linking monitoring outcomes to management review and corrective action. Common findings include missing lifecycle records, undocumented approvals, inconsistent versioning, and documentation that is overly generic. Strong documentation practices create operational clarity and accelerate audits. Operational planning ensures that AI governance requirements are embedded into everyday activities rather than treated as isolated compliance tasks. ISO 42001 requires organizations to plan, implement, and control processes needed to meet AIMS requirements across the full AI lifecycle. This lifecycle perspective includes design, development, testing, deployment, operation, monitoring, modification, and retirement of AI systems. Effective operational planning begins by identifying where governance controls must be applied. These controls may include approval checkpoints before deployment, validation requirements prior to release, monitoring thresholds during operation, and reassessment triggers when systems or data change. Controls should be proportional to risk and clearly linked to identified risks and governance objectives. Operational planning also requires coordination between technical teams, business owners, risk management, and compliance functions to ensure consistent execution. Change management is a critical aspect of lifecycle control. AI systems evolve through retraining, parameter tuning, data updates, and integration with new processes. Each significant change may introduce new risks or invalidate previous assessments. Operational planning must therefore define what constitutes a significant change and how reassessment, approval, and documentation are handled. Auditors will examine whether lifecycle controls are defined, implemented, and consistently followed. Evidence may include workflow documentation, approval records, monitoring reports, and change logs. Weaknesses often appear when controls exist only during development and disappear after deployment. ISO 42001 emphasizes sustained governance throughout operation and use, ensuring that AI risks remain visible and managed over time. An AI system inventory provides visibility into what the organization is governing. ISO 42001 expects organizations to identify and document AI systems within the AIMS scope. Without a reliable inventory, risk assessment, monitoring, and auditing activities cannot be performed consistently. The inventory serves as the foundation for governance, assurance, and accountability. A practical inventory typically captures system purpose, business owner, technical owner, deployment status, data sources, model type, supplier relationships, and risk classification. High-impact or high-risk systems should be clearly identified so that enhanced controls and monitoring can be applied. The inventory should remain current and reflect systems in development, production, and retirement phases. Lifecycle documentation complements the inventory by capturing how decisions evolve over time. Documentation may include design assumptions, training and validation results, approval decisions, monitoring metrics, incident records, and retirement justifications. This information supports traceability and enables informed decision-making when systems are reviewed or audited. Auditors assess whether the inventory is complete and accurate. They will verify that systems observed in operation appear in the inventory and that lifecycle records exist for material decisions and changes. Common findings include undocumented pilot systems, shadow AI tools, or missing records for third-party services. ISO 42001 does not mandate a specific inventory format, but it requires sufficient detail to support risk-based governance and effective auditability. Monitoring and measurement allow organizations to evaluate whether the AIMS is functioning as intended. ISO 42001 requires organizations to determine what needs to be monitored, how it will be measured, and how results will be analyzed and used. Monitoring should address both governance performance and AI system behavior. Governance indicators may include completion rates for risk assessments, timeliness of approvals, number of unresolved nonconformities, training coverage, and supplier assurance status. AI system indicators may include model performance metrics, bias indicators, drift detection results, incident frequency, and threshold breaches. Indicators should be selected based on risk significance and governance objectives rather than convenience. Measurement alone is insufficient. Results must be analyzed and acted upon. Analysis should identify trends, emerging risks, and areas where controls are not effective. Monitoring outputs should feed into management review, corrective action processes, and improvement planning. Clear ownership for monitoring activities ensures that issues are not ignored or delayed. Auditors evaluate whether monitoring activities are defined, implemented, and effective. They will review monitoring plans, dashboards, reports, and follow-up actions. Weaknesses often include excessive metrics with no clear purpose, lack of document analysis, or failure to escalate adverse results. ISO 42001 emphasizes that monitoring supports decision-making and continual improvement, not merely reporting. Internal audits provide independent assurance that the AIMS conforms to ISO 42001 requirements and is effectively implemented. The standard requires organizations to establish an audit program that considers process importance, risk levels, system changes, and results of previous audits. Internal audits are a management tool that supports improvement and certification readiness. Audit planning should be risk-based. High-risk AI systems, significant lifecycle changes, and areas with past nonconformities should receive greater audit attention. Audit criteria typically include ISO 42001 requirements, internal policies, procedures, and applicable regulatory obligations. Audit methods may include document review, interviews, and observation of activities. Auditor competence and objectivity are essential. Auditors must understand management system auditing principles and AI governance concepts while remaining independent of the activities they audit. Audit findings should clearly distinguish between conformity, nonconformity, and opportunities for improvement. Findings should be supported by objective evidence and clearly communicated to management. Auditors reviewing the internal audit process will assess whether audits are planned, conducted, reported, and followed up. Common weaknesses include superficial audits, inadequate evidence, and failure to verify corrective actions. ISO 42001 emphasizes that internal audits should provide realistic insight into system effectiveness and should drive meaningful improvement rather than checklist compliance. Management review is the mechanism through which top management exercises oversight of the AIMS. ISO 42001 requires management reviews at planned intervals to ensure the system remains suitable, adequate, and effective. Reviews provide a structured forum for evaluating performance and making informed governance decisions. Inputs to management review typically include internal audit results, monitoring and measurement outcomes, incident and nonconformity trends, risk status, effectiveness of risk treatments, and changes in context or regulatory expectations. Reviews should also consider feedback from stakeholders and opportunities for improvement identified during audits or assessments. Outputs from management review include decisions and actions related to policy changes, objective adjustments, resource allocation, improvement initiatives, and risk acceptance or escalation. These outputs must be documented and tracked to completion. Management review records provide critical evidence of leadership engagement and accountability. Auditors assess whether management reviews are meaningful and evidence-based. They will look for documented inputs, clear decisions, assigned responsibilities, and follow-up actions. Reviews that focus only on high-level summaries without decisions or actions often indicate weak governance. ISO 42001 positions management review as a central control that connects monitoring, auditing, and continual improvement into a coherent governance cycle. Nonconformities occur when requirements of ISO 42001, internal policies, or defined controls are not fulfilled. The standard requires organizations to respond to nonconformities in a structured and timely manner. This response includes taking action to control and correct the issue, addressing the consequences, and determining the root cause to prevent recurrence. Corrective action is therefore both a remedial and a preventive activity within the AIMS. A consistent process for managing nonconformities should be defined. This process should specify how issues are identified, recorded, assessed, and escalated. Sources of nonconformities may include internal audits, monitoring activities, incident investigations, management reviews, or external assessments. Each nonconformity should be analyzed to determine whether it reflects an isolated failure or a systemic weakness in governance, competence, or controls. Root cause analysis is critical. Treating symptoms without addressing underlying causes leads to repeated findings and erosion of trust in the management system. Corrective actions should be proportionate to the risk and impact of the nonconformity and should include defined responsibilities, timelines, and verification activities. Evidence of implementation and effectiveness must be retained. Auditors will review nonconformity records, corrective action plans, and follow-up evidence. They will assess whether actions were implemented as planned and whether similar issues reoccur. Common weaknesses include incomplete root cause analysis, overdue actions, and lack of effectiveness verification. ISO 42001 emphasizes learning and system strengthening rather than blame, positioning corrective action as a driver of governance maturity. Continual improvement ensures that the AIMS remains effective as technologies, risks, and regulatory expectations evolve. ISO 42001 requires organizations to improve the suitability, adequacy, and effectiveness of the management system on an ongoing basis. Improvement is not limited to reacting to failures. It also includes proactive enhancements based on performance analysis and strategic objectives. Inputs to improvement activities include monitoring results, audit findings, incident analyses, stakeholder feedback, and changes in organizational context. These inputs should be systematically reviewed to identify trends, weaknesses, and opportunities. Improvement actions may involve refining risk assessment methods, strengthening lifecycle controls, improving documentation practices, enhancing competence, or updating governance objectives. Improvement should be planned and controlled. Actions should be prioritized based on risk and impact, assigned to responsible owners, and tracked to completion. Effectiveness should be evaluated to ensure that changes deliver the intended outcomes. Improvement records provide evidence that the AIMS is dynamic rather than static. Auditors assess whether improvement activities are systematic and evidence-based. They will look for a clear link between identified issues and implemented improvements. Common weaknesses include ad hoc improvements, lack of prioritization, and absence of effectiveness evaluation. ISO 42001 embeds continual improvement as a core management principle, reinforcing that responsible AI governance requires ongoing attention and adaptation rather than one-time implementation. Preparation for certification audits is a structured activity that builds on normal AIMS operations. ISO 42001 certification does not assess intentions or plans. It assesses whether the management system is implemented, operating, and producing evidence. Effective preparation focuses on readiness rather than presentation. Organizations should confirm that the AIMS scope is clearly defined and reflected consistently across documentation and operations. Required policies, procedures, and records should be complete, current, and accessible. Risk assessments, treatment plans, monitoring results, internal audits, and management reviews should have been conducted and documented. Outstanding nonconformities should be addressed, and corrective actions should be implemented or justified. Internal audits play a critical role in preparation. They provide an opportunity to identify gaps before external auditors do. Management reviews ensure that leadership is aware of system performance and has taken decisions on key issues. Personnel involved in audits should understand their roles and be able to explain processes and controls relevant to their responsibilities. Auditors assess readiness through document review and on-site or remote evaluation. Inadequate preparation often leads to avoidable nonconformities, extended audit duration, and additional follow-up costs. ISO 42001 certification should be approached as a validation of operational governance maturity rather than a standalone compliance event. Audit scope defines the boundaries of what is assessed during an AIMS audit. ISO 42001 requires the scope to be clearly defined, documented, and justified. The scope must align with the defined AIMS scope and reflect the AI system's processes, and organizational units under governance. Clear scope definition ensures that audit conclusions are meaningful and defensible. Scope definition should consider AI system lifecycle stages, supporting processes, and relevant interfaces with third parties. Exclusions must be explicitly stated and justified. For example, excluding a high-impact AI system or a critical lifecycle stage without justification may undermine audit credibility. Scope clarity also supports efficient audit planning and resource allocation. Auditors review scope statements and test alignment with operational reality. They will verify that AI systems observed during the audit fall within the defined scope and that governance controls are applied consistently. Misalignment between documented scope and actual practices is a common source of audit findings. Well-defined scope boundaries support effective risk-based auditing. They allow auditors to focus on areas of greatest significance and enable organizations to demonstrate governance maturity. ISO 42001 emphasizes transparency in scope definition as a prerequisite for credible conformity assessment and certification outcomes. Audit criteria define the requirements against which the AIMS is assessed. In ISO 42001 audits, criteria typically include the standards clauses, the organization's AI policy, internal procedures, and applicable regulatory or contractual obligations. Clear criteria ensure consistency and objectivity in audit conclusions. Evidence sources must be sufficient, relevant, and reliable. Common sources include documented information, records, interviews, and observation of activities. Effective audits rely on triangulation, meaning that conclusions are supported by multiple types of evidence rather than single statements or documents. For example, a documented procedure should be supported by records showing it is followed and by interviews confirming understanding. Auditors evaluate evidence quality as well as quantity. Outdated documents, incomplete records, or inconsistent explanations weaken assurance. Evidence should demonstrate not only that controls exist, but that they are effective in managing identified risks and supporting governance objectives. Organizations benefit from understanding evidence expectations. Clear traceability between risks, controls, monitoring results, and corrective actions reduces audit effort and improves confidence in conclusions. ISO 42001 does not prescribe specific evidence formats, but it requires evidence sufficient to demonstrate conformity and effective operation of the AIMS. Strong evidence management practices reduce audit friction and support sustained compliance. Risk-based auditing ensures that audit effort is focused where potential impact is greatest. ISO 42001 supports this approach by requiring organizations to identify, assess, and prioritize AI-related risks as part of the AIMS. Audits should leverage this risk information to determine audit scope depth, sampling intensity, and focus areas. A risk-based audit approach considers factors such as AI system impact on individuals or business outcomes, complexity of models and data pipelines, degree of automation, reliance on third-party components, and frequency of system changes. High-risk or high-impact systems typically require deeper assessment, more extensive evidence review, and closer examination of lifecycle controls. Lower-risk systems may be audited with lighter sampling while still ensuring conformity. Audit planning should be dynamic. Changes in AI systems, operating environments, or regulatory expectations may require adjustments to audit plans. Risk-based auditing also considers historical performance. Areas with recurring nonconformities, incidents, or control failures should receive increased attention. This approach improves audit efficiency and strengthens assurance outcomes. Auditors assess whether audit plans reflect risk priorities and whether risk information is actively used rather than treated as static documentation. Common weaknesses include uniform audit coverage across all systems, lack of justification for audit-focused decisions, and failure to update plans when risk profiles change. ISO 42001 positions risk-based auditing as a practical mechanism to align assurance activities with real governance needs and organizational risk tolerance. Organizations implementing ISO 42001 often encounter recurring challenges that affect AIMS effectiveness. One common challenge is unclear accountability. AI responsibilities may be distributed across technical, business, and compliance teams without clear ownership for decisions, risk acceptance, or lifecycle oversight. This ambiguity leads to gaps in governance and delayed responses to issues. Another frequent challenge is incomplete or superficial risk assessment. AI risks may be underestimated, treated generically, or assessed only during development. This approach fails to account for changes during deployment, integration, or scaling. Inadequate inventories further compound this issue by leaving some systems outside governance visibility. Organizational silos also weaken AIMS implementation. When technical teams, risk management, legal, and business units operate independently, governance controls are inconsistently applied. Communication gaps result in missing approvals, undocumented changes, and ineffective monitoring. Third-party AI services and shadow AI tools often exacerbate these issues. Auditors frequently identify these challenges through missing records, inconsistent practices, and misalignment between documentation and operations. ISO 42001 provides structure to address these problems by requiring clear roles, systematic risk management, lifecycle controls, and evidence-based oversight. Successful implementation depends on cross-functional collaboration, leadership engagement, and disciplined execution rather than reliance on documentation alone. ISO 42001 aligns closely with the NIST AI risk management framework in both intent and structure. Both frameworks emphasize risk-based governance, lifecycle coverage, accountability, and continuous monitoring. This alignment allows organizations to leverage existing NIST AI risk management framework practices when implementing an AIMS while using ISO 42001 as the certifiable management system framework. The NIST AI risk management framework functions of govern, map, measure, and manage support key ISO 42001 requirements. Governance activities align with leadership, policy, and role definition. Mapping activities support context analysis, stakeholder identification, and system inventory development. Measurement activities inform monitoring and performance evaluation. Management activities align with risk treatment, corrective action, and improvement processes. Organizations may use NIST AI risk management framework guidance to inform risk identification, impact assessment, and control selection within the AIMS. However, conformity assessment is performed against ISO 42001 requirements rather than NIST AI risk management framework guidance. The management system structure, documentation requirements, and audit expectations are defined by ISO. Auditors may recognize the value of NIST AI risk management framework alignment, but will evaluate evidence against ISO 42001 clauses. Effective integration improves governance maturity and reduces duplication, but it does not replace the need to demonstrate conformity with ISO requirements. ISO 42001 provides the assurance and certification mechanism that complements the risk management depth of the NIST risk management framework. ISO 42001 supports organizational readiness for compliance with the EU Artificial Intelligence Act by providing structured governance and risk management processes. While ISO 42001 certification does not certify legal compliance, many AIMS requirements align with obligations for high-risk AI systems under the EU AI Act. Lifecycle governance requirements support key regulatory expectations such as risk management, data governance, technical documentation, record retention, and post-deployment monitoring. Role definition and accountability requirements align with obligations to assign responsibility for compliance and oversight. Monitoring and corrective action processes support incident handling and continuous compliance. Organizations operating in or targeting the European market benefit from using ISO 42001 as a governance backbone. AIMS documentation and records can be leveraged to support regulatory filings, conformity assessments, and supervisory authority inquiries. Risk-based planning helps prioritize high-risk AI systems and align resources accordingly. Auditors assess the effectiveness of the management system rather than legal compliance with the EU AI Act. However, weak AIMS controls often translate into regulatory exposure. Common issues include insufficient lifecycle documentation, inadequate monitoring, and unclear responsibility for compliance obligations. ISO 42001 provides a scalable framework that supports compliance efforts while remaining flexible across jurisdictions and regulatory regimes. ISO 42001 clearly distinguishes between the roles of AIMS implementers and auditors. Implementers are responsible for designing, deploying, operating, and improving the management system. Their work includes defining policies, performing risk assessments, implementing controls, monitoring performance, and maintaining documentation. Implementers translate requirements into operational practices. Auditors provide independent assessment of conformity and effectiveness. They evaluate whether the AIMS meets ISO 42001 requirements and whether it is implemented as described. Auditors must remain objective and independent from the activities they assess. Their role is to collect and evaluate evidence, identify nonconformities, and report findings clearly and impartially. Effective governance depends on constructive interaction between implementers and auditors while preserving independence. Implementers should view audits as an opportunity to improve system maturity rather than as adversarial events. Auditors should focus on evidence, risk significance, and system effectiveness rather than checklist compliance. Auditors will assess role separation, competence, and objectivity. Weak separation, conflicts of interest, or lack of competence undermine audit credibility. ISO 42001 reinforces the importance of independence and professionalism in assurance activities. Clear role definition supports trust, accountability, and continuous improvement within the AIMS. ISO 42001 provides organizations with a structured, auditable approach to governing artificial intelligence systems across their lifecycle. The standard establishes clear expectations for leadership accountability, risk-based planning, operational control, monitoring, auditing, and continual improvement. By implementing an artificial intelligence management system, organizations move from informal or fragmented AI oversight to a systematic governance model that can be demonstrated through evidence. A key takeaway from this course is that effective AI governance is a management responsibility. Technical controls alone are insufficient to address the risks associated with AI systems. Governance requires clear roles, documented decision-making, lifecycle traceability, and continuous oversight supported by competent personnel. ISO 42001 embeds these requirements into a management system that aligns AI activities with business objectives and stakeholder expectations. Auditing plays a critical role in sustaining this governance model. Internal and external audits provide assurance that the AIMS is implemented as intended and remains effective over time. Audits identify gaps, validate controls, and support continual improvement. When approached correctly, auditing strengthens governance maturity rather than functioning as a compliance burden. ISO 42001 also enables alignment with external frameworks and regulations, including the NIST AI Risk Management Framework and the EU Artificial Intelligence Act. This alignment supports regulatory readiness and enhances organizational credibility. Organizations that adopt ISO 42001 are better positioned to manage AI risks responsibly, demonstrate due diligence, and build trust with customers, regulators, and society. The standard provides a foundation for sustainable and accountable use of artificial intelligence in complex and evolving environments. This knowledge provides you with a strong foundation to aid you in the future, whether you apply it in your current role pursue further study, or contribute to shaping responsible AI in your organization. By staying informed and engaged, you will play a vital role in ensuring AI develops in ways that are safe, ethical, and beneficial for society. Thank you for your time and your commitment to this learning journey. We encourage you to keep exploring and keep building toward a future where artificial intelligence serves the needs of humanity responsibly.